Hello everyone. In this video, let's discuss about decision making. So when we go for decision making, we have if condition, if else, next is if else if later, next one is nested if else, and the last one is switch statement. So these are the 5 things which we have it in the decision making. Let's discuss one by one. Okay. So we'll start with the program hash include stdio.h. The execution starts from the main function. So I'll get the n value from the user. So I'll give int n, and then I have to get the input value from the user. I'll give scanf %d, comma, ampersand n. Now I'm going to check whether the value n is a positive number or not. That's all. If it is a positive number, I need to print it is a positive number. If it is not a positive number, I don't want to print anything. So how come I can know whether a number is a positive number or not? If the value of n is greater than 0, I can say that it is a positive number. So for checking a condition, we'll be using if statement. So how can I check the condition? If I have to give the condition in brackets. So here what am I checking? I'm checking whether the number is greater than 0 or not. So that I have to give. Which number is greater than 0? The value of n. So I'll give n greater than 0. If the value of n is greater than 0, I can say that it is a positive number. So if the condition is true, it will go inside the if statement. So I'll give a message to the output console. I'll print something saying that the number is positive. That's all. And then I'll give return 0. Let me save this and let me run the code. See, I have to give the input value called 10. See, the number is positive. And let me give a negative number and check. Let me run the code once again. I'll give -10. I'll not get anything as output value because the number is not positive. So the code has been executed. That's all. This is the if statement. We will be using if statement normally for base conditions. So whenever we are writing a program, if you are checking some base conditions, we'll go for if. Here comes one more statement. What if the number is not greater than 0? We have to print one more message. At that point of time, we have to use if else. So here I'll go for if else statement now. As usual, I'll start the program hash include stdio.h int main. I'll get the input value from the user int n. I'll get the input value ampersand n. Fine. Now I'm checking whether a number is odd number or even number. How come I can know whether a number is odd or even? If the number is divisible by 2 and remainder is equal to 0, it is an even number. If the remainder is equal to 1, it is an odd number. So here two cases I'm checking. If it is condition is true, I can say it is an even number. If the condition is false, I can say that it is an odd number. So two things are. So for that, I'll be using if else. So first I'll give if. I'll give the condition. What is the condition? N modulus 2 is equal to 0. So here what am I checking? Whether the number is divisible by 2 or not. If it is divisible by 2, I'll print a message saying that even number. What if the number is not divisible? So I'll go for else. I'll give printf odd number. That's all. I'll give return 0. This is the logic of if else. Let me run the code now. I'll give the input value as 18. I've got the output as even number because 18 is an even number. I'll go for one more number called 17. I'll run the code. Odd number. Fine. 17 is an odd number. So this is the logic of if else. So how does this if work? If the condition is true, it executes this. If the condition is false, it goes to else statement. It prints the message which is inside the else statement. Now let's discuss about if else if later. So here I'll give a scenario saying that we'll get the input value as marks from the student. Now if the marks is greater than or equal to 90, I need to print as A grade. And if the marks is greater than or equal to 75, I need to print B grade. And then I have to print marks greater than or equal to 50, I need to print C grade. And if the marks is less than 50, I need to print fail. So these are all the 4 things I need to check. So if it is greater than or equal to 90, I need to print A. If it is greater than or equal to 75, I need to print B. If it is greater than or equal to 50, I need to print C. If it is less than 50, I'll print it as fail. So here we will be using if else if ladder. What is the use of if else if ladder? First I'll check this. If this is true, I'll print this. If this is not true, I'll go for else, and again I'll check one more condition. That is why if else if ladder. So like a ladder, I'll be keep on checking. If this is satisfying, I'll print this. If it is not satisfying, I'll check this. If this is satisfying, I'll print this. If this is not satisfying, I'll go to this case, and finally I'll print it as fail. Now let me write it as a program so that you can understand it clearly. As usual, I'll start with header file hash include stdio.h int main. Fine. I have to get the input value from the user. I'll give int marks. Okay. Let me get the input value from the user by using scanf %d comma ampersand marks. Now what I have to do? I have to check the condition. What is the condition I'm going to check? If marks greater than or equal to 90. So if the mark is greater than or equal to 90, what should I do? I have to print grade A. So I'll give the output as grade A. That's all. In case if it is not greater than or equal to 90, what should I do? I have to go for else because this condition is not satisfied. So I have to go to else. Again, what am I doing? Again, I'm checking a condition. So I have to give if. So here what am I checking? If marks is greater than or equal to 75. So this condition I'm checking. If it is not true, I'll go for this. If this condition is true, I'll print grade B. If this is not true, I'll go for next case. If marks greater than or equal to 50. Here what I'll be doing? I'll give printf grade C. So if this condition is true, I'll print grade C. Now all the 3 conditions are fail. So what should I do? I have to go for else case and then I'll print fail. Then I'll give return 0. That's all. This is the logic of the program. Now let's execute the code. I'll give the input value as 85. See, I've got grade B. Let's check how we are getting grade B. So first I'll be checking 85 greater than or equal to 90. Condition is false. I'll not go inside this if case. I'll go for else. I'll check this condition. 85 greater than or equal to 75? Yes. Condition is true. So what will I do? I'll go inside this. I'll print grade B. So grade B is the output value. Now after this, I'll not go for all the cases because it is satisfied. That's all. I'll come out of this and then return 0. The program has been completed. Let's run the code once again. I'll check the input value for 35. So we'll get fail because I'll be checking this condition. 35 greater than or equal to 90? No. 35 greater than or equal to 75? No. 35 greater than or equal to 50? No. So I'll go for else case and I'll get fail. That's all. Now let's go for nested if else. Okay. So for nested if else, we'll give a condition. So we have to print a number is positive or negative number. We'll take this. Here 0 is neither positive nor negative. Correct. So here if it is equal to 0, I need to print it as 0. If it is greater than 0, it is a positive number. If it is less than 0, it is a negative number. This is the scenario we are going to go for it. So for this, we will be using nested if else. Okay. Let's start the program. Hash include stdio.h int main. The execution always starts from the main function. Okay. So I'll get the input value from the user. Int n scanf %d comma ampersand n. I've got the input value from the user. Now first I have to check whether the value is greater than or equal to 0. If n is greater than or equal to 0. So in this case, if the value is greater than or equal to 0, I have to go inside this. Again, I have to check a condition. Why? Because I am checking the value is greater than or equal to 0. But I want to print, if it is 0, I need to print it as separately as 0. If it is a positive number, I have to print separately as a positive number. For that, I have to give one more condition saying that if n is equal to 0. Okay, if n is equal to 0, I'll print a message saying that printf the number is 0. That's all. If it is not equal to 0, for sure it is greater than 0. I'll print it as positive number. I'll give the number as positive. This is what called as nested if else. Nested if else is nothing but one if else statement present inside another if else statement is called as nested if else statement. So here first I'm checking if n is greater than or equal to 0. If the condition is true, I'll go inside. I'll check whether it is equal to 0. If it is equal to 0, I'll print 0. If it is not equal to 0, obviously it is a positive number, so I'll print positive. In case if the input is not greater than or equal to 0, so I'll not go inside the if case at all. Directly I'll come to else. I'll print a message saying that printf the number is negative, and then I'll give return 0. Let me save the code and run the code. I'll give the input value as 5. I'll get the number is positive. I'll execute once again. I'll give the input value as 0. I'll get the number is 0. I'll give the input value as -3. I'll get the number is negative. So this is what called as nested if else. One if else statement present inside another if else statement is called as nested if else. So here we have to remember few things about if else statements. Let's discuss it one by one. Hash include stdio.h int main. So here I have mentioned already, if I have to give some condition, right? What if I give 0? I'm not giving any condition, but I'm giving a random number called 0. What will happen? Let's check printf. I'll give yes, and then I'll give no. This is just to no. I'll give return 0. Okay. So here the thing is, I want to give a condition. Instead of a condition, I'm giving a value called 0. What will happen in this case? Let's save this code. Okay, and run the code. So we have got no. Here remember, if the value is 0, it is considered as false. Other than 0, if we have any number, it is considered as true. Okay, what if I have the value called 1? Let's save the code and run the code. See here I've got yes, condition is true. So 0 it is false. Other than 0 it is not only 1. I might give any number called 10. Still it is given as true. Because 0 alone is considered to be false. Other than 0, all the values are given to be true. What about negative value? That also we have to check, right? Let's execute the code. It is true. I'll get the output value as yes. This is one thing we have to remember in conditions. Along with this, here, if I have a group of values, 1, 2, 3, 4, 5. Now what will it be considered? As we have discussed this in operators of comma operator we have discussed it. At the time we have discussed this. So here it is acting as a separator. So 1 I'll ignore, 2 ignore over, 2 3 over, 4 over, last value is 5. So it is considered to be true. So I'll get the output value as yes. Similarly, what if my last value is 0? As mentioned earlier, it will take first value, ignore, second value, third value, ignore, fourth, ignore, fifth, ignore, last. I have got 0. So it means it is false. I'll get the output value as no. What if I have 0 in the middle? Okay, first I'll take 1 true, then I'll go for next one true, 2, it's true. I'll go for next one 0, it is false. Go for next one 3, it is true. Go for next one 4, it is true. Go for next one 5, it is true now. Finally the condition is true. So I'll get my output value as yes. Okay, so this is one thing we have to remember in if else statements. Okay, this is another thing we have to know. I'll take a variable float f is equal to 2.5. I'll give 2.3. So I'm giving condition if f equal to 2.3. Let me run the code now. See, I'm getting no. Actually, the value of f is 2.3. Here also 2.3. It should be true, right? Why am I getting the output value as no? Here, this 2.3 is considered as a double value where the variable f is a float value. So when I try to convert the float value of 2.3 and double value of 2.3, it is not equal in binary form. It is not equal in the binary form. That is why I'll get the value as no here. I'll run the code. See, I've got the value as no. The reason behind this is float will have 6 digits after decimal point. Double will have 15 digits after decimal point. So here, this digits will not have the same value. That is why we are getting false in this case. But if I give the value as 5, 2.5, instead of 2.3, I'll give 2.5. Here, I've got the output value as true because the binary value of float 2.5 and the binary value of double 2.5 are equal. That is why I have got the output value as yes. But for 2.3, the binary value of float 2.3 and the binary value of double 2.3 are not equal. That is why I have got the value as no. Okay. This is because the precision points. Because float will have 6 digits after precision points. Double will have 15 digits after precision points. So the binary value of 2.3 for float and 2.3 double both are not equal because of those digits. But for 2.5 it is getting equal. That is why I have got the output value as yes in this case. So to remember it very easily, after decimal point, if the values are powers of 5, I'll get true for sure because the decimal values will be equal. But if the number is not powers of 5, it will not be equal. This is to remember for a easy understanding. So if I give 2.25, I'll get the output value as yes. If I give 2.235, I'll get the output value as no. See, yeah, this is one thing we can remember. Now let's go for switch statement. Okay, so I'll take hash include stdio.h int main. So switch statement is another form of nested if else. Okay, let me explain how switch statement works. I'll take a variable int, get the input value from the user. Scanf %d ampersand n. Okay, switch n. Now what I'm going to do is I'll give case 1. I'll just give a printf one. The value alone I'm just printing. And then I have to give break keyword. Then case 2 printf 2. And then I'll give break keyword. Case 3 printf 3. And then I'll give break keyword. Then here we have one more thing called default. I'll tell you what is the use of default here. None. And I'll give break. That's all. Return 0. Save the code. So here, listen to this very carefully. So here, let us assume the value of n is equal to 3. So what happens in the sense, it gives switch n. What is the value of n? 3. So automatically it goes to case 3. It will check case 1 equal no, case 2 equal no, case 3. Automatically it goes to case 3. Printf 3. 3 will be printed. After printing 3, I have given break. So break states that it comes out of this body. It comes out of this switch body. So after printing 3, it comes out of it. This is how switch statement works. Let me execute the code. I'll give the input value as 3. See, I've got the output value as 3. Now, I'll give the input value as 5. Let's check what is the output. None I have got. So here, see, n value is 5. I'll check for case 1. It is not equal. Case 2 not equal. Case 3 not equal. So it is not matching any of the cases. When it is not matching any of the cases, automatically it goes to default and it print none and comes out of it. We have discussed about switch cases. So here if it is matching any of the cases, automatically it goes to that particular case and it gets printed and comes out of it. If it is not matching any of the cases, it goes for default, it gets print of it. So break keyword helps to come out of the body of the switch statement. Now what if I am not giving break? We'll check this scenario as well. Let's run the code. I'll give the input value as 2. See here I've got 2, 3 and none. So this is what called as fall through property. So here first I'll go for case 1. N value is 2. It is not matching. Then I'll go to case 2. It is matching. After matching, this statement will get executed. Print of 2. 2 will be printed. After that, in the earlier cases, break keyword helps to come out of the switch body. But here I don't have break. Automatically it go to next case, it print 3. Then it go to next case, it print none. This is how it works. This is what called as fall through property. I'll repeat again. So when the value of n is 2, it go to case 2, print it, and it print all the cases. From that particular statement, it print all the cases. Let me give one more example. I'll give n value as 7. See, I've got only none because I'll check case 1 not matching, case 2 not matching, case 3 not matching. Then I'll go for default because there is no other option. So automatically I'll come out, print none, then comes out of it. This is what happens when we go for default, when we are not giving break keyword. Now there is a question arises here. Is it mandatory that I have to give the default only at the bottom, or I can give anywhere? Okay, let's check. So I'll take this default. I'll give between 1 and 2. Will this work? Let's check. I'll give the input value as 5. See, it works. None, 2, 3. Why am I getting none, 2, 3? See here. So first I'll check case 1. Then I'll check case 2. Then I'll check case 3. It is not matching any of the cases. Then it goes to the keyword called default. It prints none. After printing, there is no break keyword. It prints all the cases. None, 2 and 3. That is why I've got the output value as none, 2 and 3. You have to remember this. Default can be placed anywhere in the program. Okay. What if I give the value as 2 now? See, default will not be printed. 2 and 3 alone, it gets printed because I'll check case 1, not matching. Then I'll go to case 2. There is no break keyword. So I'll print case 3 also. Then I'll come out of this. So I'll get the output list 2 and 3. This is all about the switch statement. Here you have to remember one more thing. Should I give only integer value for cases? No, I can give a character also. For example, I'll give case. Character should be given in single quotes. Printf character A. Case B. Printf character B. Case C. Printf character C. Okay, let me comment this. I'll take this default. I'll keep it at the bottom. I'll comment the integer values alone. Yeah, let me save this. Here the value n is an integer. It is not matching any of the cases. See, I'll run the code. I'll give 5. It is not matching any of the cases, so it is going to none. Okay, now instead of n, I'll give integer n, I'll give character n. So I have to get the character value from the user. Let's save this. Let's run the code now. I'm going to give the character called C. See, character C and none is getting printed because case A not matching, case B not matching, case C it is matching, character C will be printed. As I am not having break keyword, none also will get printed. So in switch cases, I can give integer value and characters also. The next question arises. Can I give integer and characters both? Let's check. I'll give the character value as C. See, character C, 3 and none. So it checks case 1 not matching, case 2 not case A not matching, case B not matching, case 2 not matching, case C, yes, it is matching. So I'll give character C, then it prints 3, then it prints none. See, character C, 3 and none. Because we don't have break keyword. You can give break keyword. If you give break keyword, automatically it comes out of it. Right. This is all about the switch statements. I can give integer value for cases, I can give characters for cases, or I can give mixture of characters and integers for cases, but make sure this switch statement, whatever be that, it will match to that particular case alone. And one more thing, I can give expressions also, like 1 plus 1. Instead of 2, I can give like this. I'll give 2. See, none. Okay, it's a character, right? That's why it is not giving, it is not matching, because n is a character value. That is why it has not matched earlier. Now I'll give n as an integer value. See, I'll give n value as 2. See, from 2 onwards it is getting printed. So instead of 2, I'm giving 1 plus 1. It works. Here, switch cases should not have duplicates. I'll give case 2. Printf TWO. Let me run the code now. I'll give, see, it is giving me an error saying that switch statement should not have duplicates. Duplicate case value. It should not have a duplicate. That is why I'm getting an error here. Clear? Let me remove this. Here, cases should not have floating point values. Let's check. Instead of 1, I'll give 1.1. Let's run the code. See, case labels does not reduce to an integer constant. I can have an integer, I can have a character, but I cannot have a floating point values for cases. Similarly, I can have a string as well. See, case label does not reduce an integer constant. It can have an integer as well as a character or mixture of both. I cannot have floating point values and strings in C language. This is all about the switch cases.